Welcome back, friends. In the last video we have seen how we can perform a man-in-the-middle attack based on ARP cache poisoning. But this type of attack has some huge disadvantages. One of them is that we have to constantly send packages to stay active in the ARP cache of this client. And by sending this over and over again, the client, which is the smartphone over here, will definitely drop some other packages, which means we are losing information during this type of attack. And this is definitely something we do not want to have. Also, setting a proxy within the Wi-Fi settings is no option for us, because it will only intercept HTTP and HTTPS traffic. So if the application or the smartphone is sending data via a different service, for example MQTT, ZIP or maybe FTP, then we do not get these information because they are not related to web services, and therefore those packages will not be forwarded within the proxy settings. And this is also something we definitely do not want to have. If we perform a man-in-the-middle attack, we want to see all, and not just, single certain protocols. So how can we do this? Well, the solution for this one is we do not have to hack this device if we own this device. So if we go back into our man-in-the-middle setup over here, if we own the router, then we do not have to poison the ARP cache of this client to perform a man-in-the-middle attack, because we are already man-in-the-middle by having control over this router. And this is exactly what the setup is based on. By controlling the router, we can intercept, sniff and manipulate those packages. Okay, if they are not encrypted. But also if they are encrypted, we can deal with this. Regarding to HTTPS, for example, we will learn how to do this later on. But back to the setup, if we own this device, we can inspect, manipulate and sniff everything that goes by this device. And if this one is acting as a gateway, the smartphone is sending every package which is related to the internet through this gateway. And this is exactly what we want to have. By having control over this device, we have control over the whole network connection of this smartphone. Alright, so which components do we need for our man-in-the-middle setup over here? On the left we've got our smartphone, and on the right we've got our attacker machine, which is our Ubuntu VM. The component that's missing over here is the router. In my case I'm using a travel router from TP-Link, but the model or brand, it doesn't really matter. You can choose whatever device you like. Next, we will configure this router to act as a gateway, which means every device we connect to it will route the whole traffic through this device. And this means we are not only intercepting HTTP or HTTPS requests, we see everything. DNS, FTP, Telnet, MQTT, ZIP, you name it, we intercept it. The setup on the first time requires some steps, but afterwards we will establish a man-in-the-middle connection in under 20 seconds. We will time this later on. So it's a little bit of work if we do this for the first time, but afterwards it will be super fast to re-establish this whole man-in-the-middle setup once again. Alrighty, so let's have a look at the configuration. So the first thing we need to do is we need to disable the DHCP server in the router. So if you're connecting a device to this router, the DHCP server will provide an IP address for this device. And this is something we want to outsource into our attacker machine, because then we have also full control over the DHCP settings, which is super amazing. Alright, so how can we do this? Okay, so the first thing that's required is of course our router. In my case, I'm using a TP-Link travel router, but the brand and model, it doesn't really matter. You can choose whatever device you like. Next, I would recommend resetting this device, because you get back your lost password. And also, if you have configured this device in a certain way, this might cause some trouble later on if you perform a man-in-the-middle attack. Resetting a device, most of the time the same steps. What we need to do is we need to connect this device to the power line. And then we have to wait until the device has been booted up once completely, because if you reset the device during the boot up, this might cause some trouble. And this is something you definitely do not want to have. And then we check this device for a reset button. It's in a small hole and it's behind this hole. So we need to get some tiny thing to stick into this, which holds down the reset button for a certain amount of time. The router needs to be connected to the power line all the time. After holding this now down for at least, I would recommend 10 seconds, we can observe the LEDs on this device. They should start reflashing, reblinking. There should be some visible output over here. In my case, it starts completely reblinking all of them. After reflashing, we simply release this button and then put this device back on the table. Now we wait until the device has been rebooted, and then we are done. We have successfully performed an factory reset for this device over here. We can find all the necessary information, the default password and also the WPA key on the backside of this device. And these are now required to connect to it. Alrighty, so after the device has been rebooted, we simply connect to the provided Wi-Fi of this router. So yeah, we simply check out the credentials on the backside, and if we have no credentials, then the authentication does not require any password, which should be immediately changed afterwards. So after connecting to the Wi-Fi, the router is providing a DHCP service. So we receive an IP address. In my case, I received the 192.168.0.100. Next, we need to log in into the interface of this device, into the router, and therefore we have to identify the IP address. So most of the time it's simply just the gateway address, 0.1 or 0.254. If this is not the case for you, then we need to look it up on the vendor side. So maybe there's a certain DNS name or a certain IP address, but it should be announced anywhere on the side of the vendor. Alright, so in my case, I simply type in the IP address into the browser URL, because there should be an HTTP server running on this device. And here we have it. This is the interface of the travel router from TP-Link. The credentials, the default credentials, are just admin. So I use them to log in. After logging in into this device, we can find a lot of categories on the left side. For example, we have quick setup, we have some network settings, some Wi-Fi settings, and also the DHCP settings. But before we change anything right here, we should change the default password of this interface over here, and also the WPA key, because afterwards, after we have set up this router over here, it provides an access point which provides access to your internal network, and therefore this should be properly secured. Alrighty? Okay, in my case I can find the Wi-Fi settings over here, and here under wireless security I can now choose a new WPA key, and this is something I do right now. Okay, afterwards I hit the save button, and then this device might reboot or not. It depends on the vendor and the product you're using right now. In case it's rebooting, then just wait until it has been finished. Okay, after we have changed this password, the site might stuck at a certain point. So it seems like it's loading and loading, but the reason for this is that we have lost the connection. Because after changing the password, we have to re-establish this connection, this Wi-Fi connection, with the new password we have provided. Therefore, just simply check your Wi-Fi settings and connect back to this network over here with the newly set password. Then simply hit the refresh button and the site should now properly load. Alrighty, after changing this for the 2.4 GHz settings, we also should do this for the 5 GHz. But in my case, I'm not using it, therefore I simply hit the disable button. We can now disable the DHCP server. In my case, I can find the settings over here, DHCP. And in my case, we can see we cannot disable it right now, because we first have to assign a static IP address to this device. We can do this in the Network tab. So by clicking in the Network tab, we can now select static IP, and then we can select the Save button. And afterwards, right now, we are able to disable the DHCP server. So if we go back, then you can see, okay, we can now disable it. And that's all we need to do to set up this device. After disabling it, we will also lose the connection after a while, because this router over here does not provide an IP address to our connected devices. And if the device is not receiving an IP address in a certain amount of time, it might reconnect to another Wi-Fi. Alright, so let's recap these steps real quick. We have set or changed the default Wi-Fi password. We also disabled the 5G settings because we are not using them. If you are using them, then please also change the Wi-Fi password over there. Afterwards, we have set a static IP address for this router, and then we have disabled the DHCP service in this router over here, which means if we connect the client via Wi-Fi, we do not receive an IP address right now. Alright, so this is the setup for this device over here, and the good thing is we only have to do it once. So after performing all these tasks, we do not have to go into this once again. Alright, so the router has been set up successfully. What's next? Well, the router is not connected to anything right now, so it provides a Wi-Fi access point, but we have to connect it to our attacker machine, because the client, the smartphone in this case, will connect to this access point and it needs some sort of internet access. This will be provided by the attacker machine. That's also why we have disabled the DHCP server. Now we need to make a connection from the router to our virtual machine. And the best way we can do this is using an USB to Ethernet adapter. This type over here. Okay, in real life it looks a little bit different, but this is an adapter for an Ethernet cable into an USB cable. And this is super handy. Why? Because we can simply stick this into our laptop and then we can provide this whole Ethernet interface to our virtual machine. I mean, in case you're not using a virtual machine and you get your internet connection via Wi-Fi, then you can of course use also your Ethernet port on your real machine. But most of the time I'm working with virtual machines and this adapter comes super handy. Alright, so this adapter has an Ethernet interface and also an USB interface, and we click this together. Okay, seeing all these devices on a slide is not really helpful. And therefore, let's figure it out how we put them together in the real world over here. Alrighty, let's go. Okay, so here we have our router, our travel router, where we have successfully disabled DHCP. We have an Ethernet interface over here and we've got some other connections. But most important is Ethernet and power. Then we've got this USB to Ethernet adapter, and this looks like this one over here. We've got an Ethernet interface and an USB interface. Next, we take our Ethernet cable and then we simply put all these components together. The Ethernet cable will be plugged into the switch of the router, and the other end will be inserted into the USB to Ethernet adapter like this one over here. Next, we connect the USB adapter to our laptop, our physical machine over here. By having the USB adapter, we can forward this interface to our virtual machine. That's why we are using this adapter. The brand and model doesn't really matter, but please take care. If this USB adapter is regarding to 3.0, then your laptop should support this right now. Otherwise, please make sure that you're buying an adapter that has USB 2.0. Alrighty? Okay. After connecting everything together, we provide the power line to our router over here. In this case, it's simply a mini USB cable. We plug it into the router and then we wait until the setup or the boot process of this router has been finished. And that's all. And this is our man-in-the-middle setup. So if you want to perform this once again, we simply need to put these components together and we are done. Because we have already disabled the DHCP server in the router, and therefore we can simply reuse it as it is stick together right now. Okay? Okay, so here we are back on the slides. We have put everything together. We've got our router, which is connected to the USB to Ethernet adapter, which is connected to our attacker machine. The thing that's missing right now is the DHCP and the DNS service, which means if we now connect the client to the access point, the client does not receive an IP address. And this now sounds super complex because we need to set this up on our attacker machine because we want to have full control over this and we also want to reroute the traffic through our machine. But don't worry, we do not have to install or set up anything. There's some kind of magic happening in the background that serves our task, which is super amazing, right? The magic command for this one is the network manager. So if we type in nm connection editor, we can see a new USB interface. And the only thing we need to do to provide the DHCP and DNS service is selecting within the IPv4 settings shared to other computers. Setting this connection to shared to other computers will do the following. We have our real internet connection, which is provided by a NAT. And now we can share this connection to other devices. So by setting it to share to other computers, and DHCP and DNS service will run on our system and will automatically forward everything on this interface through our internet connection to the outside world. We do not have to care about rerouting, about DHCP settings, DNS entries or anything. All of this done is happening magically in the background. Of course, if we want to, we can take control over this and we can provide additional DHCP entries and DNS entries, which is super handy. We can verify that everything is working if the client is receiving an IP address in the range from 10, 42, 0 and then the class C nets. So in our case, the client, the smartphone, receives an IP address 156. Our gateway, which is now the USB to Ethernet adapter, should definitely have the IP address 10.42.0.1. If we receive this IP address on our USB to Ethernet adapter, everything is working properly. So we are done with our man-in-the-middle setup. Additionally, of course, we also have the DNS service running in the background that resolves all those host names. And this is also super amazing because let's say the client, the smartphone over here, wants to connect to example.org. Now, as an attacker over here, we can provide the IP address for example.org, which means the client does not have to connect to the outside domain. We can simply reroute this traffic to our local machine, to the attacker. Therefore, the smartphone is not leaving our network and we can mock up services, and provide our own services in our own network. Super great, right? Absolutely. But before we just keep talking about this, let's simply finish our man-in-the-middle setup, because most of the work has been already done. The only thing that's left to do is simply providing those two services to our USB to Ethernet adapter, and this can be done with just a single mouse click. Alrighty, let's go. Let's switch to the Ubuntu VM and have a look how we can set it up. Alright, so here we are now at our Ubuntu VM, and the first thing we need to do is we need to forward the USB interface, the USB to Ethernet adapter, to this virtual machine over here. You can do this within the settings of your VirtualBox or VMware, or whatever virtualization you are using right now. After doing this, we can simply verify that everything is working by typing in ifconfig. If the adapter is compatible to your system over here, you might not have forwarded it into your virtual machine. So simply check the USB settings on your virtual machine and see if this device is available over here. If yes, simply just click connect to this virtual machine and we should be good to go. Okay, and there we go. I have now connected or forwarded this USB interface to my virtual machine over here. In case if you have trouble, please make sure that the adapter you're using is compatible to your laptop. So for example, if your laptop doesn't support USB 3.0, then the adapter also needs to be USB 2.0, otherwise it might not work. Also please make sure that the USB interface in your virtual machine is supporting USB 3.0. In my case I have to select this separately. So USB 3.0 is not selected as a default connection. Therefore I have to go into my VMware settings and under USB I have to select 3.0, otherwise this virtual machine doesn't also support 3.0 devices. Alright, in case of any other questions or trouble or that you're stuck at a certain point, please write me a message. We will figure this out together and we will make it work for you, that you can see your adapter over here. Alrighty? Okay. Also please do not get distracted by all these connection failed messages. This is absolutely perfect because we haven't set up this connection yet. Therefore, let's have a look into this. I'm opening the terminal and I'm typing in ifconfig, and now there we go. Here we have now this adapter. This is my USB to Ethernet adapter, and the name is a little bit strange. We've got this ENX, but this one over here, that's the MAC address of my adapter. You can find it over here, this one. So if you see this right now, then it's absolutely perfect. The only thing we need to do is we need to provide the DHCP and DNS service to this adapter. And this sounds super complex, but it's some kind of magic within the network manager. So therefore, we go into the network manager and we can do this by typing in nm-connection-editor. So here we have now two interfaces. This is our NAT interface of our virtual machine. And this might be our USB to Ethernet adapter. By double clicking it, yes, we can see the device name. This is our USB to Ethernet adapter. Therefore, I'll also provide some suitable name right now that I will recognize it later on more easily. USB to Ethernet adapter. Alright, and now how can we provide DHCP and DNS to this interface over here? That this connection, the USB connection, does automatically forward every traffic to our NAT interface, to the real world, to the internet world. Well, it's amazing how easy this is. All we have to do is we have to go into IPv4 settings, and then we have to select instead of automatic DHCP, share to other computers. And then hit the save button. That's all. We are done with our man-in-the-middle setup. Isn't this awesome? Absolutely right. So if we close this one over here, and now if we type in ifconfig once again, there we go. We can now see we have a gateway address. This USB to Ethernet adapter is now in gateway with the IP address 10.42.0.1. At this point we are done. We have set up our man-in-the-middle connection. At this point we are done. We have successfully set up our man-in-the-middle connection. If we now connect the client, for example this device over here, this one, that's a real smartphone. If we now connect this device to our access point, our DHCP service will provide an IP address within this range over here. And if the smartphone tries to connect to the outside world, the traffic will be automatically routed through this interface over here into this one, which is our NAT, which is the internet side of our connection over here. Let's test this. Let's see if it's really that easy. So here we have our real device, the smartphone. We are just transferring the screen to this machine that you can see what's going on. We can see no Wi-Fi connection yet. So we simply go into the Wi-Fi settings. And then we select our TP-linked network. Or yes, in your case, I mean, you've gotten different SSID. It's regarding to the access point you have chosen. Next, we have to provide the WPA key. And this one has been changed during our initial setup. So in my case, it's the following. Of course, I'm not going to show or type this right now. I will fill it out automatically. Okay, before we hit the connect button, let's sniff on this interface. This one over here, to make sure that we are really seeing every connection right now, that we have successfully performed a man-in-the-middle attack. We can do this with Wireshark. So Wireshark is it's a network sniffer, and we can tell Wireshark to listen on this interface and sniff or record every package that's passing this interface. So in case if you haven't installed Wireshark, it's very easy. We can simply run sudo apt-get install Wireshark. In my case, I have it already installed, and if you start it for the first time, there might be some kind of initial setup. But I guess the only setting we have to choose is if you want to allow non-root users or non-sudo users to capture packages. And I deny this one, because I do not want any other users than root be able to capture those packages. Okay, afterwards we need to run Wireshark with sudo privileges. This means we are running Wireshark as root user. We are sniffing on an interface, and this requires root privileges in case if you haven't selected differently. Okay, here we have now all these interfaces, and in our case, or in my case right now, it's this interface. This is our USB to Ethernet adapter. So here we can see nothing is going on. Absolutely, because there's no client connected right now. Therefore, there's also no traffic on this interface. Of course, sometimes we can see some broadcast messages, but it's not really much right now. And let's put this now side by side. There we go. I hit the connect button, and then let's see what's going on. We hit connect, and there we go. We can see DHCP, some broadcasts, and there we go. Here's all the traffic from the smartphone right now. It's listed in Wireshark. There's a lot of stuff going on. We can see the Wi-Fi connection has been now established, and our client seems to have this address over here. Nice, it seems to work. Pretty awesome. We can verify this right now because this could be all kind of traffic. Let's see if it's really the traffic from the smartphone over here. We filter for HTTP. And here we can see the smartphone has made a request to this destination address. We can now right click into this, and then we can say follow the HTTP stream. And then we can see, okay, our smartphone has generated the following request, but we didn't receive something back from the server. So that's not a reliable case to verify that we are man-in-the-middle in this device. And so the better approach would be to simply sniff a direct connection. For example, if you're opening the web browser of the smartphone and then opening a web page. In Wireshark, we should see the request packages and also the responses from the server, if we have successfully established a man-in-the-middle connection. Therefore, let's check this out if it's working. So we can close this one over here, and then we reset this filter so that we see everything right now. Okay, then I'm opening Chrome, and I'm generating a new tab, a new incognito tab. Okay, and now I'm opening http example.org. And now we can see, yes, we have some HTTP packages over here. We can click into this green connection, right click, follow TCP string, or we can go into the HTTP package, click on this, follow HTTP string. In this case, we only see the HTTP related packages, and we can see, yes, we have requested example.org in red. This is the client. We can also find this information here. And the server is responding with the following. Here is the HTML content of this page. Nice, it's working. We have successfully established a man-in-the-middle connection. Freaking awesome, right? We can also redirect this traffic by providing additional DNS entries. For example, we can make example.org to point to a local system to us. Then the smartphone is not even leaving our internal network, so it thinks that this one is the correct server. We can do this by adjusting the DNS mask configs and some other fancy stuff. So the only problem we're having right now is regarding to encrypted packages. So for example, if we delete this filter over here, and if we scroll down, there we go. Here we can see we have some TLS connections. And this is the case if you're opening an HTTPS page. So for example, if you're not calling or opening example.org, http example.org, if you're opening https example.org, then we can see over here on the left side, we are generating some TLS packages. And TLS is the HTTPS encryption. So there is an encrypted channel in our connection. We can also take a look at this one, of course, by right-click, follow, and then TCP stream. Here we can see the beginning, so maybe we see some DNS entries, but afterwards everything is being encrypted. So we cannot see what's going on in this connection. And that's good. I mean, this is why we have HTTPS. But in our case right now, we want to see what the device is sending. For example, if we're analyzing a mobile application and this one is communicating with the backend, we need to intercept and inspect this connection. And if it's being encrypted, we need to figure out how we can deal with this. And this is something we learn in the next video. But for now, I want to show you something really amazing. Because the question is, how fast is the setup? So how quickly can we re-establish a man-in-the-middle connection? Setting it up on the first time over here, it did require some effort. Absolutely true. But if we have done this once, and let's figure out how fast we can re-establish this man-in-the-middle connection. Alrighty? Okay, so let's do this together. And let's close this over here. Let's keep Wireshark running, that we see we are losing this connection. Alright, and now I'm plugging off the USB to Ethernet adapter. So now the adapter has gone, and we can see network adapter and so on is not running anymore. We also will lose the Wi-Fi connection in a short amount of time, because the DHCP service has gone, and therefore the smartphone has no connection anymore. There we go. So the Wi-Fi settings has now gone. Okay, we also see this no internet connection. Okay, let's figure out how fast we can re-establish this connection. The only thing I need to do is I need to restart Wireshark, because removing an interface while Wireshark is still being opened, it will cause some trouble and it will crash later on. Therefore, we do not see our attack is being working. Okay, so now I have restarted Wireshark and we can see the smartphone still got no connection. We've got Wireshark on the left, we can see no interface. This is our starting point when we want to perform a man-in-the-middle attack. So we only have the devices stick together, the USB adapter to the router to the power line, and the USB adapter to our machine over here. We have forwarded this interface, and now let's see how fast we can re-establish this connection. All we need to do is I simply need to plug in the USB adapter into this machine. Because the network manager doesn't need to be configured anymore. It still keeps its configuration. Therefore, by plugging in the USB adapter to this machine, the network manager will automatically recognize this interface, provide a DHCP and DNS service based on the shared to other computers connections, and the DHCP service will be still disabled in the router. So we do not need to configure or change anything right now. All we have to do is we have to plug it into our computer. Alrighty? Okay, so let's see how fast we can re-establish this connection. I mean, the bet was on, I guess, 20 seconds. So let's see if this works out. I will keep my hands visible as far as possible, but I have to connect the USB interface. Therefore, I'm doing this right now. Okay, and here are my hands. I'm not doing anything. So let's see. Wireshark has now this interface, and on the right, now we've got also our Wi-Fi connection. So everything has been set up perfectly. We can see we are back online. But are we also man in the middle? Therefore, I have to select this interface. We hit start, and let's see. We do not see any requests right now, so we have to wait until the smartphone makes requests. And there we go. It sends out some quick packages, whatever they are, but we can see, yes, we have re-established this man-in-the-middle connection. So that's all we need to do right now. The setup, yes, it was a little bit of a mess for the first time, but re-establishing this right now, super easy. Nice, isn't it? Okay, so this is how we can set up or establish a man-in-the-middle connection. And by having this setup, we are able to see everything, every single request of the smartphone, and we are also able to manipulate certain important network informations. For example, DHCP settings and also DNS settings. Alrighty, so the thing we cannot do right now is we cannot manipulate these packages. In Wireshark, we only see them, but we cannot intercept, modify, and re-forward them. This is something we are going to take a look in the next video, and I'm super excited about this. We also learned there how to deal with HTTPS connections. So how to break off SSL. Alrighty? Okay, I'm super excited about this one, but yeah, feel free to play around with this setup a little bit. And afterwards we have a look in dealing with HTTPS connections. Alrighty? Okay, I'm super excited and I'm looking forward to see you in the next video.